Deep inside a remote limestone mountain in Van Horn, Texas, engineers are carving a deep shaft. Inside this massive, dust-filled cavern, they are constructing a monumental mechanical clock of staggering proportions designed to survive millennia. The project, developed by the Long Now Foundation and backed by figures like Amazon founder Jeff Bezos, is designed to tick accurately for the next 10,000 years. That equals the entire recorded history of human technology. Passive monuments, like the pyramids, survive millennia simply by standing still, but movement generates friction, drains energy, and eventually destroys a machine from the inside out. To survive deep time, engineers had to rethink how a physical structure interacts with constant motion. The primary threat inside the mountain is cold welding. When metal surfaces sit in close, nearly motionless contact for centuries, they begin to fuse together at the molecular level. Standard mechanical lubricants, like oils and greases, offer no help here. Over hundreds of years, they evaporate, oxidize, and attract abrasive rock dust that grinds down the gears. The solution is a completely dry mechanical system that operates at imperceptibly slow speeds. The clock's chassis is built from marine-grade 316 stainless steel and titanium, metals selected specifically for their high resistance to environmental corrosion. To counter cold welding, this animated diagram shows engineers replacing metal-to-metal contact with specialized ceramic bearings. Zooming in, these ceramic components possess natural corrosion resistance. They physically cannot bond the way metals do under extreme pressure. By separating the moving metal parts with ceramic barriers, the engineers eliminated the threat of mechanical fusion without using a single drop of liquid lubricant. Moving those massive components requires continuous power. The clock must generate reliable energy for 10 millennia without solar panels, batteries, or human intervention. Engineers harnessed a purely passive thermodynamic process, capturing heat from the daily cycle of sunlight entering a sealed air chamber near the top of the shaft. Looking at this cross-section diagram, we see the heated air expands a dense graphite cylinder. That thermal expansion literally pushes a lever, translating temperature shifts into the mechanical energy that drives the clock's pendulum. But power is useless without accuracy. Earth's rotational speed and elliptical orbit shift microscopically over thousands of years, meaning standard clocks will inevitably drift out of sync with the sun. This diagram illustrates the equation of time cam, a physical brass gear correcting that celestial drift. Synchronizing with the noon sun, the cam's asymmetrical shape calculates the difference between solar and mechanical time, physically nudging the pendulum to stay accurate. The machine guarantees its precision by tying its moving parts directly to the thermodynamic and gravitational forces of the solar system. Internally, the clock acts as a survival mechanism. Externally, it functions as a system of mechanical computation, where the physical arrangement of gears acts as code. It features an auditory output designed to generate a completely unique sequence of melodies every single day for 10,000 years. Musician Brian Eno developed the specific algorithmic sequence for this chime generator. To execute this complex algorithm without electronics, a cascading series of Geneva wheels rings an arrangement of 10 bells in varying order. Converting continuous rotational energy into intermittent movement, the result is a slow, methodical cascade of massive metal interlocking and shifting over centuries. The massive mechanism operates as a computational engine, running a 10 millennia algorithm entirely in physical brass and steel. Maintaining a machine across thousands of years of unpredictable environmental and societal shifts requires absolute transparency. To achieve this, the clock relies on what its creators call Bronze Age technology principles. The mechanics are highly complex, but the physical laws governing them are entirely visible to the naked eye. Future generations, regardless of their level of technological advancement, can inspect, understand, and repair the system using basic tools. Ticking at 1/10 the speed of a standard mechanism, this clock forces a completely different perspective on time. Instead of a 12-hour dial, visitors look at a black globe displaying the exact shifting positions of the stars overhead. The clock of the long now exists to track deep time, serving as a physical monument that asks us to look past our immediate lives and act as good ancestors for the distant future.
say a massive thank you for sticking around and completing this journey with me. So let's get into it. Did you find these complex engineering concepts as utterly fascinating as I did?
To get more amazing construction content, just follow this blueprint. Thumbs up, share, subscribe, and hit that bell. Which leaves one final question. What incredible structures are we going to build in our very next adventure?